Greetings to all. I'm Dharshan, Assistant Professor from the Department of Electronics and Instrumentation Engineering. Today, we're going to see about model-based system engineering in which the hardware-in-loop test is being considered. The hardware-in-loop test is a testing method used in industries like automotives and aerospace. It stimulates the behavior of the physical systems by integrating real hardware into a virtual environment. It is a typical setup, the system under the test conditions to a computer or controller indicating with behavior components like mimic real-world behaviors. This allows comprehensive testing of functionalities, performance, and interactions in a controlled environment, reducing the need for extensive physical prototyping and field testing. HIL is cost-effective and ensures reliability before deploying complex systems in operational environments. The desktop computer contains the real-time capable model of the controller and plant. The development hardware also contains an interface with which to control the virtual input to the plant. The controller hardware contains the controller software that is generated from the controller model. The real-time processor contains the code for the physical systems that is generated from the plant model. So here I have developed a small practical example where the EV motor with respect to the speed is being tested. So this is the practical example of an hill test model which is developed for an EV motor vehicle. So here this is the motor which is used in an EV device where it is a DC brushless motor with an RPM of 490 and with a voltage of 48. So this is the driver unit which drives the motor, and the driver unit is connected with an SMPS module, a separate SMPS module which gives us a supply of 48 volts. So this is the system desktop computer in which the software has been generated, where we have utilized MATLAB as the system software for the device. So this is the accelerating device with the acceleration of which increases the motor speed with respect to the amount of acceleration. So this is the target software which is being utilized. So target software is MATLAB. So this is the model which has been created for the motor environment. So this is the model generated for the motor, and these are the conditions and the different platforms which is created for connecting the motor with the real-time system. So these are the parameters of the motor which has been utilized for this test bench. So first, initially, so we have three different conditions that to be tested and to be checked before the model-based system engineering hill test is to be considered. So initially, the hardware structure is to be considered before developing a model. The parameters of the model is to be fed to the software to test the basic functionalities. So here, these are the parameters such as the back EMF and the RPM are tested in accordance with the acceleration. The output of the back EMF is considered. So this is the back EMF model which has been developed for the motor that has been utilized for this test bench. So the output of the model is a trapezoidal waveform where when the speed of the motor is adjusted, the trapezoidal waveform, the size varies. The time of the trapezoidal waveform varies. And in the second condition, the test condition for the to connect the different accelerating points with respect to speed of the motor. The speed conditions are virtually tested to the model to identify the difference in the actual system. These are the virtual models through which the match the real hardware that is being deployed to the real-time system. So when the real-time model is being started and the condition is being monitored, the values of the motor is being tested here. So the values of the motor with respect to voltage and the RPM are being shown. So finally, the target model is deployed into the targeted software and the virtual environment to test the conditions of the hardware. Under these conditions, the model reactions with respect to the real-time output are compared in the way of graphical representations. This would help us in calibrating the hardware to reach the goal before deployment.
So when the targeted software and the model is considered, so we get two different outputs with respect to the measured speed from the model which has been created and the output from the motor which has been developed. So this difference in the real-time output are compared in the way where the calibration of the real-time hardware can be done before deploying it into the real-time environment.
Finally, the hill test saves us the deployment time, testing time, and the cost of the system which is being deployed. Thank you.